Yeah, I got to download it anyway. Okay. So let's start sharing. Now, I think I went over a couple of these with another student. These are really good for picking, how do you pick the right test? Because there's not enough information to actually solve these. So we'll just make this up as we go. But the better part is, how do you pick the right test? Because if you pick the wrong test and you pick the wrong spreadsheet, everything messes up. So, all right, Sylvia is a medical researcher. She wants to study the metabolism rates of caffeine in men and women. She uses couples for her comparison and devises a study where both spouses of a couple will eat the same foods because she believes that diet has a significant effect on metabolism. She tries to pick couples where the general health of both spouses are similar. The study requires blood to be drawn after consuming caffeine in similar amounts adjusted for body mass. She has 37 couples in her study and wants to determine if the amount in caffeine in the blood is different between men and women. 40 minutes after consuming the caffeine, she takes a blood sample from both the husband and the wife and measures the caffeine still in the system. What hypothesis test should she use? So before you answer that question, I always like to say, is it categorical, quantitative, or regression? So what kind of data are we collecting here?
So she's collecting the caffeine bloods in different men and women.
Okay.
But yet, where she grabbed them is from spouses of similar general health.
Right.
So, in a way, that is more of, it's not regression.
Okay.
Trying to consume blood amounts. She has 37 couples. So, would it be categorical?
You think it's categorical? What do you think the categories are?
Actually, no, it's not category because the only category is the different couples, but the same category because it's similar spouses in both general health, and all that she's doing is the caffeine blood levels of different men and women in 40 minutes consuming caffeine. So it's actually quantitative then because there's no categories.
Okay, yeah. So quantitative, yeah. And it's quantitative because
It's just all she's trying to do is the blood, the amount of caffeine in blood from eating.
the amount of caffeine in blood, which is a quantitative variable. Perfect. Okay. So yeah, so you change your answer, and that was good because part of it was to say, what are the categories? The categories would have to be yes, no, true, false, something like that. And so there's obvious. This clearly isn't that kind of data. You're measuring the. Okay. So it's quantitative. So let's go with the null and the alternative hypothesis. So what do you think the null and the alternative hypothesis would be?
The null hypothesis would be that the couples would have the same blood sugar.
Okay, so how do I write that as a?
So it would be, so there's 37 couples. 40 minutes consuming caffeine. So it would be N equals, what is the other one? Give me a second. No, know how to write it. Yeah, would it be N equals O? No, it's not O. I can't remember what N equals though.
Well, N usually refers to sample size.
Yeah.
So you're trying to do a hypothesis test about the sample size?
Or no, we're not doing sample size. All right, we were doing blood sugar.
Yeah, we're doing caffeine in blood. So
so it's not N, it's I'm not here right now. What is it?
okay, so one of the rules is your null hypothesis always has to do with a parameter. So what are some examples of parameters?
What do you mean, examples of parameters?
So would like P or P hat, would one of those be a parameter?
P hat would be a parameter because
Nope.
the mean of P hat is P. So parameter would be P then?
Parameter is P. What would be another example?
So P hat's not a sample.
P hat is a sample.
It is?
And so it's therefore a statistic. It's not a parameter.
Okay.
So you'd never use P hat in a thing, in a hypothesis state. Null or alternative hypothesis. So you could also use mu. You could also use sigma.
Mean sigma.
You could also use D. You could also use R. You could also use, that's a pretty good list. M. So which one of those letters do you think I should be using and why?
Not sigma because it's not standard deviation.
Okay, we'll cross that one out.
And one thing I'm trying to remember is definitions of everything.
Okay.
I'm horrible with definitions. Or at least remembering definitions.
Okay, well, so let's go through them all though. What does P represent?
The mean of I can't remember what the other P is.
Okay, so you said mean, but I would call that a proportion.
The proportion?
It's like a mean, but usually. So does this have to do with proportions?
No, it doesn't.
No. So we're gonna cross that one out. What's mu?
So n is sample size, mu is, what is x? Like I said, I can't remember definitions.
Okay, so you don't know what mu stands for?
No.
It's the population mean.
Population.
So that's a possibility.
Mm-hmm.
What's D? Or mu sub D?
Would it be, isn't that standard, not standard, that's sigma standard deviation. M is margin of error, isn't it?
Well, this is actually unit 4. That one's going to be slope.
Slope.
We're not going to do that yet, but we will eventually.
Okay.
What's R?
I don't remember those.
R is your correlation coefficient. Oh, you know, you learned that in unit 4 also. So we'll throw that one out. And D, what's D?
D is,
D is difference for paired
difference.
test. So we're going to throw that one out. So the only one it could be is mu. Okay?
Mm-hmm.
So mu, and it has to have an equals in it here.
Mm-hmm.
So what do you think?
So it's mu equals,
What are we comparing? What are we trying to
we're
compare?
comparing the blood samples.
So she wants to know if the amount of caffeine in blood is different between men and women. That's what we're trying to determine.
So mu equals, we're actually looking for the population between those two, isn't it?
Yeah.
So it'll be mu equals n, because n is population, is it not?
No. N is sample size.
Sample size, okay.
So we're comparing men and women. So we're comparing mu of the men
to mu of the women.
to mu of the women.
Okay.
Does that make sense now?
Yes.
Okay.
And then
We could say mu1 equals mu2, but I'd rather write it this way.
okay.
Okay.
Yeah, I like it that way better. And then with the alternative hypothesis, it'd be the difference. So mu of men is not equal to the mu of women.
Right. We just want to know if it's different.
Yeah,
We
if
don't
it
know
was
if the men
less
are
than or
higher.
greater than, it would change it up, would it not?
Say it again.
If it was less than, like say we want to find if men are greater than women in it, then it would be different.
Yeah, men are greater than it would be here, or
Yeah.
we could say men are less than
It'll be
be
there.
there.
Okay.
They just said different, so we'll do not equal to.
So mu is, so n is the sample size. Mu is the
Mean.
mean.
Population mean.
Okay. And
Yeah.
d is
So,
difference.
so if you're getting those confused, we've got to get that cleared up before the next test
Which is next week.
which is next week. So yeah, make sure you get that down. Okay. Now the next question is this a t, a z, a chi-square, or an f?
What is f?
F is a nova.
Nova, yeah. It's not a nova.
Okay, we'll cross that one out.
Since we don't have a standard deviation, there is none up there, just talking about that. So it's not a z.
Not a z, you're going to cross that one out.
I'm actually saying it's a t-test.
That is correct. T-test. Now, which t? Is it a one sample?
Not a one sample t-test.
Or a paired t?
So this is more of a line of a dependent because they're trying to get similar. So it actually would be wouldn't it be a two sampled t-test? Because it's cocking for a similarity of them.
You're saying it's a two sample?
Wait. Or is it paired T?
This is always the hard one, right?
Yeah, I know it's not a one sample for sure.
Okay, so we'll cross out the one sample. Okay. Now we have to decide, is it two sample or is it paired?
Yeah. It's a paired sample t-test.
And it's paired because?
They are similar, and what they're trying to find out if they are the same, or if there is a difference in them.
Okay, so this one is a tricky question, and you were right the first time. It's a two sample.
It is two sample. See, that's. Can you explain how is it a?
I can explain, yeah, and here's why. Now this one's really good because they keep talking about couples. Couples. They said it all over the place, but they're actually comparing the metabolism rates of men and women. Okay, so they're not pairing up the couples. She's trying to take the blood sample and she's comparing the difference between men and women, not between husband and wife.
But so if they said it was between the husband and wife, then that actually would mean it would be a paired T.
Now, so this is correct. Now, on the other hand, if I had said it was a paired T, that would also change this. Instead of being mu men to mu women, I would say that the difference is 0. And I would say that the difference does not equal 0.
Okay.
Okay. So that's why these are kind of related, because if you get this, the null hypothesis is affected by this.
Yeah.
So this is a paired T, but this is a two sample T.
Okay. So pretty much if she's saying what she wants to study the metabolism rates of caffeine in couples instead of in men and women,
right,
then it would change it to the difference and make it
And if they were doing it as a true paired, they'd probably have to say man minus the women or women minus the men. But they'd have to do it that way. And then that would change your null hypothesis to be d equals 0, and that would be a paired.
Okay.
Okay.
So there's mu.
So that was a really tricky one.
It was. So mu is the mean, n is the sample size, d is the difference.
Right.
I forget what so that's it for now. It's those ones.
Right.
And then sigma is standard deviation.
Is population standard deviation.
Yeah, population standard deviation. But out of z, t, and what's the other one between t and f?
Chi-square.
Yeah, chi-square. What is exactly that again?
So that's what we're going to learn. If we're not learning it this week, we'll learn it next. Okay.
Okay.
So a lot of people mix up the chi-square test. So a chi-square test is a categorical. So you know how the ANOVA is 3 or more means?
Yes.
A chi-square test is generally 3 or more proportions.
Oh, so that can actually get sort of confusing if you don't read it correctly.
Exactly. Yeah.
Okay.
So, yeah, and I can't remember if we're going to learn that this week or next, but we will definitely learn that.
So you said F was ANOVA?
Right.
Okay. And yeah, I knew Z and T. Okay.
Okay. So do you want to do one more just for fun?
Yeah, let's do one more. I was about to ask you if we could.
All right. So the Levitt Group is a survey consultant company. They have been a family-owned business for over 30 years, but the father retired 3 years ago and left the company to his 2 children. They have been contracted by a paper producer to gauge the preference of their design logos and whether or not the preference is dependent on age group. They design a study where they want to ask which of 2 logos someone prefers. They will also ask the respondents for some demographic data, which will include their age. They want to determine if there is a difference in the preference of logos for customers in the 25 to 44 age group and customers in the 45 plus age group.
Hey, can you give me 1 second real quick?
Sure.
Hello? Hello? Yes. Hey, how's it going?
Okay. So, all right. So the first question we want to ask is this categorical, quantitative, or regression?
What exactly is regression again?
Regression is unit 4.
Okay, so we're not there yet.
We're not there yet. So, but I want to get you used to answering that question. But basically, is X related to Y? That's regression.
So it's not regression.
Okay.
Being contacted and they want to know whether or not the preference is dependent on age group. And the design is 2 logos of which someone prefers, and they're doing the age, but they said they want to determine the difference in preferences of logos of customers in 25 to 44 groups and 45 plus. So in a way that would actually consider to be categorical because you've got 2 different age groups and 2 different logos and they're trying to find out which logo they would prefer.
Okay.
So I'm going to say category.
You're saying categorical, and what are the categories?
The 25 to 44 age group and the 45 to plus age group. And with that, they're trying to determine which 2 logos they will prefer.
Yeah, so logo 1 versus logo 2, is that what you're saying? The categories? Yeah. You said the groups first, but the groups are the groups, but yeah, the categories. Yeah, okay. That's correct. So this is categorical. Okay. All right. So now the question is this Z, T, chi-square, or F?
It's not chi-square.
Why not?
I don't know what chi-square really is, though.
Okay.
I know it's not F. I know it's not ANOVA because it's not 3 or more means.
Okay. We'll cross that one out.
It's not a Z-score, though, because we're trying to figure out if differences. between versus logo 1 and logo 2. I'm honestly saying it's a t-test.
Okay. So 2 of the ones you ruled out are both correct. And in fact, I have to tell you a funny thing. So I had a student, this is actually a chi-square test of independence.
Yeah, okay.
Okay, you're like, it's not that one. Yeah, it is that one. Or it could be a Z2 proportion test. You could actually do this one either way. So I found this out when I had a student that challenged me. I don't know if it was this problem, but a similar problem. And he said, why couldn't you do a 2 proportion test? And then I found out that a chi-square test and a 2 proportion test, they will give you the exact same p-value, exactly the same, which really surprised me when I did that, because I was like, let's plug in some numbers. And all of a sudden I was like, oh my gosh, you can do it either way. The way this one's written, and so this will be an introduction to the chi-square test, which you'll learn. Here, let me find out when we're going to learn this, because I was asking about it. That's why I went ahead with this one, because I figured, oh, well, we're close enough. So let's see.
We're in 2 proportions now.
We're in 2 proportions, and then, yeah, so this is at the end of the week then.
Okay, so it's next.
So the next week. So the test is early in the week, so remember to take the test earlier. I'll have to.
I was going to actually do it Saturday. That's the day that I'm off, and I don't have to stress about other homework.
I want to make sure I'm right on that, because let's see. Hopefully, I went to the right class. Okay. So week begins March 8th.
It is next week. I do know that for sure.
Okay, so this week.
Oh, it starts on the 19th.
18th and the 19th.
It ends on the 21st. So yeah. It starts Monday. Dang it, I hate when it's on Mondays.
Yeah. So it is going to start. So you're going to learn that this week anyway. So this is kind of your preview. So the idea here is with a chi-square test of independence. Let me show you how we set. Well, actually, I'll just show you, because we got a new spreadsheet here.
Yes, I actually have that one downloaded where it talks about wrong one. The 2 proportions chi-square version.
It's not chi, it's chi. But
sorry, yeah, chi-square.
Yeah. Spreadsheets. I'm getting smarter. The categorical data analysis.
Yep.
Okay. So the chi-square test, you can actually do. This allows you to do up to 6 rows and 6 columns. So you could think of this as, which logo do you like? And then you could also do this one as 25 to 44 and 45 plus, right?
Okay.
So let's say you had, so this is, in fact, this is what's really interesting. Just a quick demonstration. Typically, you're going to do it more than 2. You'd have more than like 3 choices here. But if you only have 2, let's say that you have 25 people that like this one, and you got 15 people that like this one, and you got 14 people that like this one, and you got 37 people that like that one, or whatever. Okay? So you can do a chi-square test of independence. Notice my p-value. So well, let's back up a second. So since this is a chi-square test of independence, your null hypothesis, I'm going to give this one to you since H, oh my goodness, H sub O. Then you're going to say that logo is independent of H. And your alternative hypothesis is logo is not independent of H.
Okay.
Because the question is, it might be dependent, but there might be some sort of a lurking variable. And so we don't want to say that it's dependent. And
so are these always going to be independent, or are they?
Yeah. So the null is always going to be independent. The alternative is always going to be not independent.
So with the chi-square, is it always going to be an independent study, or is there actually going to be dependent studies in it?
It's always going to be independent versus not independent.
Okay.
Okay. And so,
So when they threw up there inside there,
will never be it's dependent because, for example, is education level independent of gender? Well, it could be there's some other lurking variables, and so you don't want to say, oh, look, I remember there was one we did, and it was saying that women get more bachelor's degrees, but men get more master's and doctorates. Does your education depend on you being a man or a woman? Like, is there something biological that says women can't get master's degrees?
okay.
So you wouldn't want to say that education would be dependent on gender. You'd say they're not independent, and because there's something going on, like bias or something like that, that's causing that to happen. But it's not genetically. Oh, women can't get master's degrees because of their gender. Like it's not specifically dependent on gender. It might be dependent on stereotypes or something like that. And so that's why we don't say dependent here, we say not independent.
Okay.
So it's just because statisticians are a little bit anal.
All right.
So, but anyway, so what I wanted to show you here was, so in this case, based on your p-value, would you reject the null or would you not reject the null?
We would reject it because it's below 0.05.
Reject the null, and so therefore your conclusion would be
that it is not independent.
Logos are not independent of age.
Of age, yeah.
Whatever, group, can't spell. Okay, now here's the interesting thing. If I set this up a different way, since this is just 2, generally with a chi-square test you're going to do more than 2, but if you did exactly 2, okay, so you can see here 25 out of 40, so that would be 25 out of 40, isn't that, here it is, let me see this, 25 divided by 40, oh, you turkey. Oh my goodness. Equals 25 divided by 40, 62.5%. Okay, so that's that. So 62 and 37. So I could turn this into a proportion test. Oh, actually, here, I'll do it. 25 out of 40. And for the other one, it was 14 out of 51.
Yeah.
14 out of 51. And I'll do we'll say it's a not equal here. So what we would say is, oh, well, here's what's interesting. That's rounded. Let me add another digit here. Look, that p-value, 0.008, is exactly the same as that p-value there.
Huh.
So I could have done this one. It was a student at one of my UVU classes, and he says, why isn't that one a 2 proportion test? And it could have been. I could have said, okay, the proportion is, so let's see, if I do this one, this is people who like logo 1, and this is people who like logo 2. Okay, so I could have said P1 equals P2, and your alternative is P1 does not equal P2. You can kind of compare here. Let's see, can you? So P1 hat's 62.5, P2 hat's 27.5. Clearly those are different. And so actually, I probably, the way I did that, no, that's correct.
Actually, X2 is the people, logo 2 is people that like X2. So 14 is people that like 14. Or logo 2 or whatever.
Yeah, you're right. I should have done 37. Let's do that.
Why is 37 instead of 51?
37. That's
Why?
People who like logo 2.
So, okay. But I thought row 1 was the
one. Oh, you know what? You're right. So now this one is
I was just talking
This
about
is
your.
age group 1. This is the 44, whatever, the 25 to 44,
Uh-huh.
and this is the 45 plus.
Mm. That's both added together.
Yeah,
Okay.
yeah. So at any rate, so you'll get the exact same p-value.
So the statistics though over here
So
on
if you have two proportions, you can either do a two proportion test or you can do a chi-square test. But the chi-square is typically done when you have more than 3 proportions.
okay, so you're talking about like if they had different more age groups or they had
Yeah,
more
more
logos.
age groups or more logos. Yeah, either way.
Okay, so it's almost like a nova, but a nova is three means, where this is actually three different groups.
3 proportions. Yeah,
Proportions, yeah.
yeah, yeah.
Okay.
So that's your preview. Yeah, and if you only have 2, you could actually do it either way. And the funny thing is, because I had a student that was arguing with me, and I was like, oh, let me prove you wrong. And then I was like, oh, you're right. You can do it either way. So I actually gave him extra credit because he argued me wrong. So yeah, you could actually do this one. The way this is written up, it appears to me the author of it is trying to do a chi-square test of independence because he's asking, is your
Whether or not.
preference dependent on age group? And so
And the whether or
he's
not.
going this way. He's going this way. But you could actually do this one as a two proportion test as well, and it would give you the same answer. Now, just the reason why this is just as a FYI. So when you're looking at the two proportion test, the two proportion test is a z-test. Okay.
Mhm.
So here's the z-score. You get 3.53, and then if you use, then you could plug that into the normal probability applet, and you would get 0.0008. Now, the chi-square test is actually 2 z-tests squared. That's why they call it chi-squared, because it's actually the z-test squared. And so the reality is, when you take two normals and square them, you get a chi-square test, and that's why this number exactly matches that number. So they are related.
Isn't the z-score also the test statistics too?
Well, this is the test statistic for the z is 3.53. The test statistic for the chi-square is 11.25. And in fact, if I take this 3.353 and I square it, I'm going to get 11.25. Oh, why didn't that let me do that? See, 11.25.
Okay.
So yeah, so test statistic refers to either the z or the chi-square or the f or the t. If I'm looking here, these are my test statistics here.
Okay.
But just going back, that's why these two tests are related to each other. Okay. The chi-square works better if you have 3, like if I had, let's say I had 3 logos and then 15 and 25 or something. Okay, so that would also say reject. The logos are not independent of age group.
So it only would be good for the two proportions or whatever if there's only two groups.
Yeah, the chi-square and the two proportion are the same test if you have exactly 2 proportions. If you have 3, you have to do it the chi-squared way.
Okay, I prefer the chi-square way. It seems
Yeah,
easier to me.
So, but yeah, so the way this one is written, they were pushing you towards the chi-square test of independence, but if you only have 2 proportions, they'll give you the same answer essentially.
Okay.
So, all right, so that was definitely some high-powered stuff there. You won't get that in the lesson.
No, you won't. And I'll be here Thursday too to go over
Okay.
more stuff.
Yeah, so I will just mention here, the more you guys can come, if you're struggling with picking the right test, this next test is going to be hard. And so if you want to practice that, I will practice that again on Thursday, and I will practice it again on the following Monday. Does that make sense?
Sounds good. I'll be here.
All right, perfect. Okay.
Thank you.
You're welcome. We'll see you later.
All right. Bye.
Bye.